All right, welcome everybody to another live stream. My name is Brian McLogan, and I am going to work through quiz number 2 in our trigonometry unit. So I had to get this live stream done before the end of the year because, as I've kind of talked about on my channel, we're now working into our chapter test as well as to our semester exam. So I wanted to make sure that I had covered all the material for my students. So that's why I'm just kind of jumping in here live on a little bit different time period. And, I just kind of turned on the general chat just so I could kind of focus and I could get this over with as far as the working through this quiz. So, and for the second quiz for trigonometry, we're going to cover, basically identifying the parts for the sine, the tangent, and the cosecant graph, as well as evaluating the composition of functions, trigonometric functions, and their inverse. Then we're going to go ahead and work on, Then we're going to work on just some multiple choice questions, again, dealing with our trigonometric functions and looking at the inverse. So on this quiz, for this quiz is over really only 3 sections, basically just graphing and inverses of our trigonometric functions. And again, this is really the last quiz that I gave my students for this year. And we just took it this week. And so therefore I'm going to work through, provide the formula sheet, hopefully, or provide the key. So therefore they can use it to study off of their mistakes. And hopefully you gain some benefit from it as well. So let's go ahead and get started. All right, so the first one is just identify the amplitude, the period, the phase shift, the range of the following functions. So the main thing we want to start off here is, going through basically our definitions. Amplitude is going to be absolute value of A. Remember, that's the half distance from the max to the min. So that's going to be at 1/2. Now, before I really can figure out my period, or really to do the phase shift, the best thing to do would be to rewrite this by factoring out the B. And this is something that I reminded the students before they took the quiz to factor out the B when you're identifying those transformations. And a lot of them still had trouble doing that. Either they forgot about it or they did not like the fact that there was a fraction. But again, just remember, dividing out of 2 is like multiplying by 1/2. So if you multiply 2x by 1/2, you're going to get x. If you multiply pi halves by 1/2, you're going to get pi fourths. And that's why I even wrote it down wrong. And again, we can always check our work, right? You can always check your work by factoring by multiplying. 2 times x is 2x. 2 times pi fourths, is going to give you pi halves. So in this case, we can see that our b here is 2. And I forgot to write that down. Let's label our work. How about that? Because I told my students to label their work, so I should probably do it. So this is the amplitude. All right, then the period, if you guys remember, I'll just do a little bit of extra work here on this one. I will at least show you the formulas. So again, amplitude is absolute value of A. Okay, so period is going to be 2 pi divided by the absolute value of B, which in this case is 2. So it's 2 pi divided by 2, which is equal to pi. Now the phase shift is, again, that's going to be your C. And since you're adding a pi over 4, that's going to be a pi fourths to the left. So I told students they could abbreviate that with PS, and that's going to be left pi over 4. Now there's another point for you guys that do the graphing portion. Again, what you could also do is set that equal to, set the original equation equal to 0. This is something I taught my students. And this is kind of like the starting point. So I don't teach graphing anymore. But if you did have to graph it, you would start, instead of starting at 0, you would start at a negative. I'm messing all this up. So your starting point here is you always start at 0, right? The initial period of sine starts at 0. But if you have these transformations on the inside, so you're going to subtract pi halves. I'm like messing up with my gauge here on my space. Then you'd have 2x equals negative pi halves. And then you divide by 2, divide by 2. Now it starts at x equals negative pi over 4. So again, you can see how that left pi over 4 is changing, because instead of starting at 0, now you're starting at negative pi over 4. So that is just another way to kind of understand that. And I'm just going to kind of put it in a box. So therefore, you can kind of see that another way to understand how the transformations are going for that graph. Now, the next thing is really the range. So the range, we got to understand the vertical transformations. Well, again, this graph, the sine graph, the initial period of sine graph looks like that. Goes up to 1 and -1. So if we are going to be vertically compressing the graph, then it's just going to go as high as 1/2 and as low as -1/2. So the intercepts don't change. Oh, come on. I'll just kind of put some points. It'll be a little bit easier for me to follow from there. There you go. So now you can see that the graph only goes as low as -1/2 and as high as +1/2. So the range was -1/2 to +1/2. Okay, and again, so using the starting point, using also an X scale, you could go ahead and sketch a rough graph. Basically, take this graph, the logograph, and then shift it pi/4 to the left. Would be just a rough sketch of what the graph would look like. I don't teach the detailed graphing anymore. It just kind of took too much time away from my class. All right, so the next one is identify the period and the vertical transformation. So again, reflections of vertical asymptote. Again, like a lot of time, I think where a lot of students made their mistakes here was the fact that they were not really understanding what their B was. So again, like I remind you, rewrite this as tangent of -1/4 x minus 1, right? Because again, like 3/4 is the same thing as 1/4 times 3, right? And so a lot of students, when they did the period and stuff like that, they did, B was 1 or -1 or 4. And no, B is -1/4, as you can see. The other common mistake was students adding the period. The definition for a period is going to be pi divided by the absolute value of B. So a lot of times they still use 2 pi for that. And that is a common mistake. So obviously the absolute value of -1/4 is just going to be 1/4. When you're dividing by a fraction, you can just multiply by the reciprocal, so that's going to equal 4 pi. There was no amplitude, because remember the definition of an amplitude is the half distance from the max to the min. And since a sine and cosine are the only two functions that are bounded, those are the only two that have a max and a min. So an absolute max and a min. So therefore, since tangent and cotangent are unbounded, they're not going to have an amplitude. There was no phase shift, so we didn't need to worry. Let's see vertical translation. You can see we're subtracting 1 on the outside. So most students got this one. So that's going to be down 1 unit. And then we have reflection. So you're multiplying by reflection inside. Remember, everything that's happening outside the function is a vertical reflection. So if you have a negative on the outside, that's a reflection about the x-axis because that's vertical. So if you have a negative in the inside, that is a reflection about the y-axis because that's horizontal. So therefore, I can just write reflect the y-axis. And then asymptotes was, again, the other issue that a lot of students had because they didn't remember like where the asymptotes occur. So what I told them to memorize was these coordinate points. Like where is cosine undefined, right? Where do asymptotes occur for cosine, or tangent, I'm sorry. Tangent, remember, is y/x. So you can see at this angle, which is pi/2, tangent is going to be undefined. The y, 1/0, is undefined. And then, so it's at pi/2, and then if you add pi to it, halfway around the circle, you're going to get another undefined value, which is 0, -1. And if you keep on adding or subtracting pi n number of times, you're going to have an undefined value. On the graph, that is going to produce a asymptote. Hey, thank you very much, a good old member. Finally, I got one of my members to show up for one of these, so I really do appreciate it, Adeline. And thank you so much for joining in. If you do have any questions, I will be more than happy to answer any questions after that. But yeah, with a lot of these live streams, I've been doing membership only, just trying to get some different encouragement from people that have obviously supporting the channel in that way. And then, so I'm very, very happy to see you on here. So thanks so much. And again, I will answer any questions. If you do have any questions, I will stay after this quiz. But let's go ahead and finish on the quiz where we have here. So we have pi/2 and we have 0, negative, or 0, -1. So it's undefined, so those two values. So that's where the asymptotes are going to be occurring. So therefore, all we're going to do is we're going to take what's inside of our function, and we're going to set that equal to our asymptote equation, which was pi/2 plus pi n. Now we just need to solve for x. So to solve for x, I'm going to multiply by a -4. Multiply everything by a -4, right? So therefore, that's x equals -4 times pi/2 is going to be a -2. Did I do that right? Yeah, or just multiply or multiply by negative 4. So that's going to be a, I guess, oh yeah, it is, right. Okay, so negative 2 pi. And then this is going to be a negative 4 pi n. All right. Now, this negative 2 pi is actually redundant, and so therefore I accepted this answer. But in reality, we could also just write it as negative 4 pi n. And also, we could actually even simplify that even further, but just doing as a positive 4 pi n. It'd be exactly really the exact same. They're going to hit the same values, just for different values of n, where again, n represents any integer. Now, this is something we talk more about next chapter. So, any one of these versions of the equation, I accept it for my students because we'll spend more time in that next chapter, which would be solving, trigonometric solutions. All right, for the next one, we had to identify the period, the vertical transformation, the vertical asymptotes and range. So again, another vertical asymptotes and range. The period was really, again, the same thing. In this case, we have our A is 1 and our B is 1. So again, remember the period for cosecant and secant is just going to be 2 pi divided by B, or absolute value B, right? So that's going to be 2 pi divided by 1, which is 2 pi. We didn't have to worry about the phase shift, which would have been right pi. Our vertical transformation is obviously going to be up 1. So you can see I kind of threw some basic ones in there for hopefully the students. And that helped a lot of students out. Some students only got the vertical transformations, but hey, you can work with something. And let's do the vertical asymptotes before we get to the range, because the range is kind of difficult. So the vertical asymptotes, going back up to here, you can see the cosecant, remember, is 1 over y, right? Well, these two values are defined for 1 over y. However, these two values, 1, 0, and negative 1, 0, are not defined at 1 over 0. So in this case, the negative 1 over 0 and 1 over 0 there's undefined. So you can see that angle is 0 plus pi, right? And then 2 pi and then 3 pi. And so you can keep on adding n. So the asymptote equation in this case is for cosecant is pi n. So again, you just take whatever's inside your function. X minus pi equals pi n. And then we can just add pi. So therefore, x equals pi plus pi n. And just like in the last equation, that pi plus pi n is redundant. So really, we could have a simplified equation as pi n. However, I accepted both solutions for the students. Now, it's important to understand the cosecant is how that relates to the sine function. Because in the last one, did we talk about sine? No, we talked about, yeah, we did do sine. Okay. So remember the sine function, just the standard period or the initial period here looks like this, right? Okay, so we have 1 to negative 1. Now, this graph, again, it doesn't really matter if it's being shifted over pi, like that's not going to change the range, right? But what has happened is the graph did get shifted up 1. So now the graph, instead of it, I'm going to change my colors here. Oh, I got to say, oh, well, very good, Anna. Well, if you do have any questions on basic algebra, please answer the question. That's awesome. I'll be more than happy to answer any of the questions, as I taught a lot of basic stuff all the way up to calculus. So if you do have any questions as I'm working through this, please feel free to add it in there, and I'll be happy to answer those for you. All right, so here is now the graph being shifted up 1, right? So we took the red graph and we shifted it up 1. Now we just need to understand that relationship with the reciprocal function. Well, remember the reciprocal function we talked about in class was that mirrored image, right? So we have this asymptotes here, but it's that mirrored image. So instead of the range of the blue graph, so the range was originally at negative 1 to 1. It got shifted up 1, so now it's from 0 to 2. But again, that's the range for sine. The reciprocal function is going to be from negative infinity to 0, and then from 2 to infinity. So it's just that mirrored image relationship that we need to understand. So in this case, we have our range is going to be from negative infinity to 0, union 2 to infinity. Okay. Next example is just evaluating the composition of two functions. So basically what I went through with my students here, is just to go ahead and evaluate from the inside first. So we have the sine of 4 pi over 3. So, when you're evaluating using the unit circle, the first thing you want to do is go ahead and sketch a graph. So 4 pi over 3 is going to be in the third quadrant. That is a point on the unit circle, which is going to be a negative 1/2, comma, negative square root of 3 over 2. So therefore, we can see the y-coordinate here, right? The sine of that angle is the y-coordinate on the coordinate point of the unit circle, which is negative square root of 3 over 2. So I can rewrite this as the sine inverse of negative square root of 3 over 2. Well, now I basically need to figure out, well, when is the sine of negative square root of 3 over 2 going to equal, for sine of what angle is going to equal negative square root of 3 over 2, right? Well, we can't just say it's that original angle because we have to follow through the restrictions of sine inverse, or the restrictions of sine to obtain sine inverse, which is basically between negative pi halves and pi halves. So this angle does not meet the restrictions between negative pi halves and pi halves. This angle does. And this angle is just an extra pi thirds. So instead of 4 pi over 3, it would be 5 pi over 3. But again, the problem with 5 pi over 3, even though the angle has a terminal side that lands within the restriction, it goes outside of that restriction. Like that angle is larger than pi halves. So the only angle we can do is a negative angle that just goes from our initial side down to here. So again, if this is 5 pi over 3 and half all the way around the circle is 6 pi over 3, then we're pi over 3 away. Since we're going in the negative direction, you can see that the answer is going to be a negative pi over 3. That's a horrible 3. So we'll fix that. All right. Okay, so now let's go and look into the next example. So the next example, you can see we're finding the inverse. Now again, it's really, really important for my students to understand that when we're using the sine inverse, we're looking for the angle, right? This is basically saying the sine of what angle, let's call it theta, equals x over the square root of 2. That's what this says. That's what you're thinking to yourself. The sine of what angle equals x squared of 2. Well, once I do something like this, I recognize, that means this is going to give me an angle, right? The sine of what angle is x over square root of 2. So this is an answer of sine, inverse x over square root of 2. So in reality, what I'm trying to find is the cotangent of theta. Well, I don't really know theta, right? And I don't know what the answer of theta. I don't know what the angle is here. However, this gives me enough information to go ahead and draw a triangle. From chapter 1, or from like the first section, we could draw a triangle given this information. So by drawing a triangle, let's just draw any right triangle. Let's put theta here. If this is sine, that means that's going to be opposite over hypotenuse. Now I can just use the Pythagorean theorem to go ahead and solve for this missing side because I need cotangent, right? Which is adjacent over opposite. So let's call this A. And let's just go and use the Pythagorean theorem over here. So therefore, this is going to give me, let's see, this is going to be a squared plus x squared equals the square root of 2 squared. And again, we need to solve for a. So I'm going to subtract an x squared. I'll get a squared is equal to square root of 2 squared is going to be 2 minus an x squared, square root, a equals the square root of 2 minus x squared. I do not have, it doesn't make sense in this problem for us to have any positive or negative side lengths. There's no like restrictions or anything. So therefore we're just going to, that's why we're only using the positive version. And so therefore a is equivalent to 2 minus x squared. So now my final answer is again my adjacent over my opposite. So it's going to be 2 minus x squared all over 2. There you go. All right, so that was the free response portion for my students. And then we went on to the multiple choice. So, one thing I told students, I give a lot of multiple choice, problems. Every one of their tests is something. I was, if you notice, like all their tests are part multiple choice, part free response. But one of the things, I wanted to deal with, the reason why I do that is for students so they can, start looking at these. I want to see all of their work, up here. I want them to show their work, show their understanding. And then for these, I want them really to kind of like think about the problems and And really, but I don't require them to show step by step how they're achieving the problems. I want them to kind of think about what is the best, fastest, easiest way to answer some of these questions based on the information that's given. It's a different type of thinking that you need to apply. Some of these problems are rather easy. Some of them are kind of tricky and confusing. So you have to be kind of careful. You got to make sure you read through everything and don't just automatically pick an answer that you think. Like, make sure that you are understanding the question as well as the answers correctly. I don't think there's any tricky ones in here, but I don't know, had some things to say. So the next one says determine the amplitude in the period. So we have a cosine, so there is an amplitude. Remember, that's the absolute value of A, which is going to be positive 3/4. So therefore, automatically, I know that that's not the answer and that's not the answer, right? So it's between these two. Then it says the period. So again, remember the period is 2 pi divided by 2/5. Well, when you're dividing by a fraction, that's the same thing as multiplying by the reciprocal. That goes to 1. So basically we're left with 2 pi times 5/2. Well, now the 2's divide out, and we're just going to be left with a 5 pi. And you can see the answer there is A. The next one says sine inverse of negative 1/5. I'm not sure. Typically, I like to use parentheses when there's a negative number, but that shouldn't have changed anything. That is the same thing as sine inverse of negative 1/2. And this is very similar to the problem that we actually just did, right? So when is sine equal to negative 1/2? Well, based on the unit circle, there's two angles, here and here. And, you know, this angle, I'm not going to write them down there. That angle is 7 pi over 6, and this angle is going to be 11 pi over 6. So if you look at the unit circle, you know, like the unit circle that my students used, you would see those two angles, but neither of those two angles work because remember, the restrictions for sine to evaluate the inverse is between negative pi/2 and pi/2. So the only way to find the angle is to identify, it has to be this terminal side, this angle here, but we just need to go in the negative direction. So we need to understand, well, what is the reference angle? Like, how far are these two angles away from the x-axis? And the answer is pi over 6, but we need to go negative pi over 6. We can't go pi over 6 because that'd be in the first quadrant, which would not be a negative 1/2, right? So therefore, we have to go ahead and use those two. All right, the next one is determine the exact value for arctan. So just remember, tangent inverse of -1 is the same thing as arctangent. Remember, tangent is y over x. So a lot of people get confused with the -1. They think they look at the x and the y coordinates, but remember, it's the y coordinate over the x coordinate on the unit circle. So the only time it's going to be 1 is when you have the same coordinates, right? X and y coordinates. Well, that only occurs on our fourths. So, pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. But again, the restrictions of tangent are between negative pi/2 and pi/2. And obviously, if tangent's negative, it has to be down here. But again, we can't use this angle, right? So we have to use the same angle that is in the opposite direction, which is, again, going to be pi over 4 away, but just in the opposite direction. So that answer is C. For number 8, now this point is, again, kind of like the last problem we had. There's not a point on the unit circle, or at least not a coordinate that I recognize on the unit circle. So therefore, I'm going to draw a triangle. Now, again, the arctangent is looking for an angle. Let's call this angle alpha. So therefore, the secant of alpha. Okay, so remember, when you're using inverse tangent or arctangent, you're looking for an angle, right? So let's just say whatever that angle is, let's call it alpha. So from that point, I can draw a triangle. Let's put alpha right here. Here's my right triangle. So again, tangent is opposite over adjacent. Now, I could use the Pythagorean theorem to figure this out. But again, or you could understand your Pythagorean triples, right? But my students didn't have a calculator. So let's kind of do it from this perspective. The secant is going to be hypotenuse over adjacent. So automatically, I know 15 has to be in my denominator. So it's not this one, and it's not that one. So my only two other points here is going to, which one is it going to, represent? Well, it can't obviously be 8 because then the hypotenuse would be the same as this one. So it's not going to be that one. And then hopefully you recognize that this 15, 8, and 17 is a Pythagorean triple. And otherwise it would just actually make sense, multiplying like 15 times 15 is 225. 8 times 8 is 64. That's not going to be 32 squared. Like 32 squared, even 30 times 30 is 900, right? So that's kind of way off. So therefore, you can see the answer would be C. For question number 9 is, what is the exact value of the composition? Now, this one's kind of interesting because the angle is in the first quadrant. So we have pi over 3, which is right here, right? Now, the restrictions of cosine to evaluate the inverse is between 0 and pi. So the cosine of pi over 3 is just going to be 1/2. So therefore, now we're evaluating, well, what is the cosine inverse of 1/2? Well, again, it has to be either in the first or the second quadrant. Any angle in the second quadrant would be a negative 1/2. So therefore, it's just going to be this angle in the first quadrant. So it's just going to be back to pi over 3, which is the answer B. Now, number 10 was actually a extra problem. If you noticed on my quizzes, I only give 9 questions, but for some reason, I did an extra problem. So let's just kind of go through this. The amplitude, remember, is the absolute value of A, which is absolute value of -5, which is 5, which was answer C. So there you go, ladies and gentlemen. I am now finished with my second quarter of instruction. This was the last quiz that we were covering for my course. So obviously in my class, we are now preparing for our chapter test, and then we will be doing our semester exam. So I still have a lot of content videos as far as for my teaching that I will still be uploading onto my channel. So hopefully as you guys are preparing for your own semester exams or chapter tests, hopefully those will help you out. But otherwise, as far as my live streams are going to go, I will be back with these live streams not until the next year. However, for my open Q&A, that is not just for members, it's open for everybody. I will still be doing those on Sunday evening, looking at still 9 o'clock as long as nothing else comes up. So make sure you guys stay tuned for the community channel, and I will be posting that. So thanks, guys, for tuning in. And thank you very much, Adeline, for being a member, and as well as joining me on this live stream. So I really do appreciate it. I start a new semester, Jan, so I have questions for it. Well, absolutely. Well, I will make sure that I also try to post a little bit ahead of time, so therefore you know when I will be going live next time for these member-only ones. So therefore you can definitely take advantage of being a member and asking whatever questions you want, and not for me having to battle through like 100 questions as I'm doing a live stream. But I will also be doing that battling for all of you on our open Q&A. But if you want your question answered, reminder, please make sure you guys go on the community tab and ask your question there, or you can obviously message me on Facebook, and I'll be more than happy to adjust them for there. So otherwise, guys, you have a great weekend, and I will see some of you on our next open live stream. Cheers. Why is that? Oh, that's so weird. The sun came down.